Hi, everyone, and a warm welcome to this webinar on exploring the societal potential of the VIEWS early warning system and a review of the ERC proof of concept project that we have been working on for the past 18 months. My name is Angelica Lindqvist McGowan, and I work as Head of Operations and Outreach with the VIEWS team. And speaking today is also my colleagues Simon and Sarah. So I will start by handing over to Simon to introduce himself, and then we'll head over to Sarah.
Hey all, my name is Simon van der Marten. I'm a senior researcher at the Peace Research Institute of Oslo, where I work as part of the VIEWS core team. I'm also the team lead for the model development and deployment team. Yeah.
And hi, and welcome from my side as well. My name is Sarah Callis. I work as a research assistant at VIEWS in the Oslo team, and I work across teams in both outreach, model development, and research. And we're super excited to have you here. I see a lot of people trickling in, but I think we can start off, Angelica.
We should also say that we have quite a few other members from the VIEWS team in the audience today, and I'm sure you will interact with many of them in the chats or during the Q&A later on. But the reason we're here today is to present views and present the progress we've been making for the proof of concept project. So what is VIEWS then? Well, we are a collaborative academic initiative by Uppsala University and Peace Research Institute Oslo. We comprise a core team of about 15 to 20 people, varying a little bit over the course of the year, which are divided between Uppsala in Sweden and Oslo in Norway. We're also supported by a global network of about 20 to 25 research associates. And one of the key outputs from this academic initiative is an advanced early warning system for global forecasting of armed conflicts. The system mobilizes a large roster of diverse data sources in tandem with advanced machine learning techniques and provide monthly updates with forecasts extending 36 months into the future. Beyond the early warning system, we are also an academic research consortium. So we are compiled by a series of different projects that study and predict the risk of armed conflict and its societal impacts, all led by Professor Håvard Tegre, who is also the director of VIEWS. This is everything from the pilot academic project that started VIEWS with an advanced grant, the proof of concept that we're talking about today, 3 different conflict impact projects, and many other smaller projects that you can see on the list here. The proof of concept grant then, what is this? Well, this is a lump sum grant of 150,000 euros that spans over 18 months. This is available to previous recipients of an ERC advanced grant for frontier research. The purpose of this grant is to allow researchers and research team to explore the commercial or societal potential of their work, essentially to repackage their frontier research into a commercial product, or in our case, a public social good. This is a rather unique funding opportunity for activities that seldom receive sufficient funding from traditional research grants. So we're very grateful to have received this grant and be able to work a little bit more on our outreach activities. So when we applied for this grant, we were quite far away from where we are today. We were still rounding off the advanced grants with 2 pilot models, or well, one replacing the other. This was called VIEWS 2018 and VIEWS 2020. And all of our output, or most of it anyways, was tailored towards the academic community. We made monthly datasets available upon request, and we summarized our monthly forecast for the 3 months ahead prediction window in 9 to 10 page monthly reports, just summarizing the general findings. Beyond that, we didn't really offer much towards the practitioners community, which is what we wanted to focus on with the proof of concept. Beyond the advanced grants, we had also made a lot of standalone infrastructure developments that were still distinct from the production pipeline. For example, we had started developing a new data infrastructure that we today know as VIEWS 3, and a web-based client user that interacts with our internal database. We also had a number of transferable outcomes from collaborations with, for example, UNESCO and the UK FCDO, such as an expansion of our geographic coverage to the Middle East, development of an API, and a model for predicting the number of fatalities, along with some surrogate or interpretation models from a collaboration with the UK FCDO. But at this point in time, they were single standalone developments that weren't yet part of our production pipeline. So when we presented or submitted our proposal to the ERC, we wanted to make use of all of these things, combine them into our production pipeline, and focus more on outreach towards the practitioners community. So one of the key objectives to make sure that we could sustain or maintain providing this early warning system moving forward was to secure the organizational structure required to run a live, fully deployed and operational early warning system. This was facilitated by entering into a formal research consortium between Uppsala University and Peace Research Institute Oslo, as we have staff in both locations and our director also is employed in both places. And in doing so, we were able to sort of pull the resources from the different research projects that we had at both institutions and also expand the amount of or the extent of different funding opportunities we had in both countries. So this is today the Violence and Impacts Early Warning System Use Research Consortium. Like I said before, we also wanted to incorporate the standalone innovations into the public view system, and we wanted to tailor the project outcomes for use by practitioners and policymakers across the triple nexus. Now, in practice, this meant working closely with our key user group to provide ample documentation of the data that informs the views model, how the model works, and how well it performs. We also wanted to make the data readily available in the formats that were actually desired or requested by our users, beyond the academic audience, that is, and explore and showcase how the views predictions can be leveraged across the triple nexus. With that, I will hand over to my colleague Simon to talk a little bit more about the expansion of the views early warning system. Simon, the floor is yours.
Thank you so much, Angelica. So very quickly, I'm sure we are all somewhat familiar of what machine learning model is, but just to give people an overview of how we use these models to forecast future scenarios, right? So machine learning is basically just a branch of artificial intelligence where computers learn directly from observed data without being explicitly programmed. So it's a combination of computational algorithms and statistical methods. And the essential task is to parse a very large data set, and then from that data set, learn to extrapolate patterns found in the data set into, for instance, the future. In our case, of course, the final objective is to create predictive models that could forecast the probability, but also the expected intensity of future violent conflicts. So we use an extended suite of open source data covering from 1990 and onwards. We have over 200 unique predictors at our country level and 100 at the pre-grid level. I'll return to that unit of analysis in a second. The features currently part of our system are selected based on decades of peace and conflict research. So for those of you that have been dabbling in that, will find many of these features rather familiar. And we source all our data directly from the data providers, usually through their various APIs. We strive to have immutable definitions, meaning that a feature is what it's called and it will keep being that. We have uniform coverage across time and space, to the extent, of course, that our data providers have that, but we take great care to interpolate where we need to do and normalize where we need to do. We update our data at least annually, and for our conflict and media data, we update monthly. So I will not go deep into this, but these are just some examples of the data that we use in these big machine learning models. We have conflict event data from the Uppsala Conflict Data Program. We have the conflict and protest data from the ACLED. We use a suite of different data sources from the DIMSCORE project. We use a number of variables from the World Development Index, from the World Bank. You can go on. Yes, nice, thanks. We have data on different climate and societal vulnerability factors from various sources. We have more, what would you say, inert structural features that we get from the pre-grid, such as urbanization, mountainous terrain, light night emission, things like these, things like that. And then from our collaborators in Barcelona, we have the topic modeling of Factiva news data from Muller and his Barcelona-based team. So these different data sources we subdivide into different themes, some of them in regards to conflict history, some of them in regards to climate, and so on. Thanks. So right now, our main target, what we try to forecast, is conflict level, right? You can easily imagine us forecasting a number of these other features that we talked about, and that is something we are working on in our pipeline. But currently, our prime target is future conflict, and all our initial models focused on that, and all models that are currently deployed focus on that. And the conflict target we use is the conflict definitions and the data from the Uppsala conflict data program. So that is the kind of violence we are kind of. Oh, can I get you to go back a second? Thanks you so much. That is the kind of violence that we kind of focus on. So we basically try to predict future level of UCDP violence. UCDP is updated monthly with candidate data, then revised once a year. So that is one of our most kind of well-maintained data sources. Now you can move on. Thanks. So there is a lot to be said about how we evaluate the performance of all our various models and our ensembles of individual models. I will not get too deep into this right now. It's a whole last discussion. I'll be happy to expand upon it during Q&A. But basically, for our regression task, we right now use mean squared error as the primary metric to evaluate how well our models are doing. And for the classification task, us trying to predict the probability of conflict, our prime metric is average precision currently. But again, there is a lot of active research going on within our team and with our collaborators to think about better ways of doing that. Super. So the UCDP data covers 3 different distinct types of violence: state-based conflict, non-state-based conflict, and one-sided. We have been working with all these kinds of violence, and we have models that predict these different kinds of violence currently. And the initial focus was the state-based conflict. For various reasons, these are the easiest to forecast. One of the reasons is that those are the kind of conflicts that occurs most often. But we are developing models right now. We have models that are running in our experimental environments that forecast the 2 other kinds of violence, non-state based and one-sided. And we also have reported our results in academic dissertations regarding forecasting of these. We originally focused on Africa only. We later expanded. I will get back to that. And we originally focused on predicting the probability of any kind of violence. So for country level, following the UCDP definition, that means the probability that a country would see more than 25 battle-related deaths in a year. And for the pre-grid level, which I alluded to earlier, is the subnational geographic grid, where each grid cell, you can think of it as a pixel, is at the equator approximately 55 by 55 kilometers. It is defined in decimal degrees, so changes a bit as you move north and south. But here it was the probability of at least 1 battle-related death a year. So that's useful, but we wanted to do more, and we wanted to have a better understanding of the intensity of violence. So one of the first things that was changed was that we wanted to predict the number of fatalities. So that means going from only a classification task where we try to look at the probability to also a regression task, trying to estimate the number of people that would succumb to violent conflict. This was initially a standalone model, but it has been expanded to a large set of our models right now. So we have models that does both. We also have models that does both at once. We started using a larger suite of input data. We started using new, more advanced machine learning algorithm, new evaluation protocols. These are things that are still in very active development, and I will talk about that later. we switched to to the third iteration of the view system, which we are currently working on. We expanded to the Middle East, right now the PG, the pre-grid model, covers both the Middle East and Africa, while the country level model covers the whole globe. Yeah, this was amongst other things enabled by our collaboration with Esquire. Those models, as I mentioned before, that we have in production are currently focusing on state-based conflict. But again, we have in our experimental sandbox models that forecast the two other kind of UCDP defined conflicts. So that will be out in deployed productions soon enough. So from a user perspective, one of the big advantages from moving away from only having probabilities of any conflict to fatalities is that implicitly, as I noted, when we say that we predict the probability of conflict, it is really the probability of, at country level, 25 battle-related deaths. But you might be interested in the probability of 100 or 1,000 battle-related deaths. And the classical form of classification we did would not be able to do that. And if we were creating models for each of these thresholds, we will have very quickly thousands of models. So predicting fatalities allows us to give that information to the user much more easily. If the user is only interested in conflicts of a certain size, or most interested in conflict of a certain size, using forecasted fatality will help the user kind of pass that information. We also aggregated to new level of analysis. We are moving towards and have already implemented some amount of better assessments of the prediction, the uncertainty involved in our predictions. This is also a very active research project right now. We have a number of different models in our experimental sandbox that does produce uncertainty estimates. We are also in the kind of final stages of finalizing a predictive competition, where the explicit goal was to come up with new qualified ways of estimating the uncertainty around our forecast. Nice, thanks. Yeah, that was me for now. I will return to you later. Angelica will take over again now.
Thank you so much, Simon. Yeah, so one of the most common questions that we receive from our users is, of course, what drives our forecasts. Now, understanding how advanced AI and machine learning models generate their predictions can, of course, be quite challenging, and rightfully so. Typically, models with more complexity perform better than simpler ones, but this complexity also makes them harder to interpret. So to address this issue, we are exploring various different solutions for enhancing the interpretability of complex AI models. Eventually, this will be integrated into the Views framework, but likely not for quite some time still. So in the meantime, we have developed a series of interpretation models that help users assess what input data variables or broader themes thereof that have the most substantial isolated impact on our predictions. We refer to these as our surrogate models. In practice, these are linear regression models that use the main Views prediction as the dependent variable and a selection of indicators as the independent variables. And the result can be seen as an indication of how much of the main Views prediction that can be attributed solely to the selected features. And an example of this can also be seen here on the slide, here isolating the contribution from conflict history when looking 3 months ahead into the future. But because these models ignore all other contributing factors, it is important to keep in mind that these models only provide a partial insight into the model, and they're not designed to indicate causal relationships. Nevertheless, they are a very helpful tool to peek into the model dynamics and assess the relative importance of the selected drivers. Now, you can read a lot more on this in the user guide on our websites. You can explore the data in our monthly prediction data sets, and as well as the upcoming version of our data dashboard that we will get a demo of shortly. As I mentioned earlier, one of the other main objectives of the proof of concept project was to improve our model documentation, with particular emphasis on its applications for practitioners and policymakers working across the triple nexus. Here we've come quite a long way since we started. We have put together an exhaustive record of the nearly 200 raw input data variables that go into the views model, and that is prior to implementing any kind of data transforms to them, which produces new features that we also use in our model. This is available via the current model page on the views website, and it's always incorporated into the public model code that we produce. This, however, is predominantly tailored towards the more advanced users. It's not very intuitive if you don't have a background specifically in machine learning or data science in general, but it's there for anyone who wants to inspect the model code in more detail or in a more intuitive format directly from our website. But we have also made extensive updates to our websites. So this includes dedicated pages for each generation of the views model. So regardless of which one you are looking at, whether you want to look at some historic predictions that we made or the latest ones, you will find a description of the model in question on our website with references to academic articles for each of them or papers, if that's the case. And last, we have launched a model documentation series that zooms in on different aspects of the views model in much greater detail. This includes a paper on the levels of analysis and the dependent variable, a paper on data partitioning and time shifting, ensembling and calibration, albeit the last two are more geared towards the academic community still. And last, we have an extensive evaluation of how well our model performs, but this one is currently in editing, so it will be released soon, we hope. We continue to strive for maximal transparency from the selection of the input data variables to production of the final predictions, and make all of our model code available in the views forecasting repository on GitHub. We have also expanded the documentation of our API, including a wiki section with a user guide for querying and retrieving data from our API, and a list of all of the available data sets. Sarah will talk a little bit more about this in a short while. We have also created a repository specifically tailored to the practitioners community, which will be completed with some tools for exploration, analysis, and visualization of our data. The content of this repository is based on the most common requests that we receive from the practitioners community and will be updated regularly as more come in. Using these tools provided as Jupyter notebooks does require a Python installation on your local computer, but you can also open them in online tools such as Google Colab, for example. But they are also very carefully documented so that anyone can use them regardless of previous experience with these types of tools. Now, as I'm sure you've been waiting on, I will stop sharing my screen and hand over the screen to our consultant, Henrik Valerian, who has been working on a new version of our data dashboard, which will probably be the most useful tool for most of you who wants to explore, visualize, and access some of the views data. So Henrik, please go ahead and show us. Okay. So we have, or Henrik has been working on this dashboard for quite some time. Those of you who are familiar with views since before have probably seen the old version of the dashboard that's currently live on our website. The old one has our predictions from 2021, but has been stalled since then when we moved over to the fatalities models, the predicting fatalities models. So this new version will serve to deliver the latest forecast from the model. It has or will have 4 different map views. The first one is predicted conflicts, where you will be able to see the latest forecast for predicted fatalities and the probability of armed conflict. And as soon as we have loaded the data here, you will be able to get a peek of what this looks like. So you just go in, you choose the map view that you want to use, you choose the prediction model. In this case, it's only fatalities 2, the data release, the month that we release the data, type of violence, which right now is only state-based, and then the variable that you're interested in. Then you get this lovely view where you get the global coverage at the country level. You get a small description of what variable it is that you're looking at, and you have a slider in the top as well where you can move between the 36 different forecasting months. And when you click on a country, you will get a line graph that shows the entire 36-month window of our predictions. And if you go into the subnational view, you will be able to see the grid level predictions as well. And the same thing goes here. You can click on a country and get a little bit more information, get the line graph, and also scroll through the 36 months of predictions that we offer. So everything is changed directly on the dashboard for you. There is also a button there to download the data that you've selected as a CSV file if you prefer to use that method. But there are many other ways of retrieving our data, as Sarah will speak about shortly. The second map view is the predicted de-escalation view, as we call it. Here we are trying to put our latest predictions in relation to a historic average of recorded fatalities to provide some sort of information or an indication of whether we predict an escalation of the conflict that is happening right now or a de-escalation or just no change at all. So here you use the latest data set by default, and you choose the historic period that you want to compare with. You can choose the last month, a rolling 3, 6, or 12-month average of recorded fatalities. And this is from the UCDP Uppsala Conflict Data Program data. Then you choose the variable that you're interested in, type of violence, in this case, still only state-based violence, and you get this view here, where you see the predicted change in fatalities in relation to the historic period that you chose. In this case, we're looking at the last month. So in the pop-up, you will see the number of change that we're expecting. You will see a small description of what the dashboard is showing, and you also see the sources, both from the data sets, the predictions that we're showing, and the conflict history data that this is compared to. And same thing here, you can go into the subnational view and get the details for each grid cell as well. As I spoke before about surrogate models, we do have a view for the surrogate models as well, an interpretation view, where you will be able to see the results in terms of how much of the final prediction that can be attributed to selected features. Here, we've only got a small selection of surrogate models at this point, but it's to give you a little bit of a teaser of what the surrogate models look like, and we hope to expand these in the future. But the same thing goes here. It looks basically like the predicted fatalities view. You just choose the variable, in this case, the surrogate model that you're interested in, to see the relative contribution from that specific variable or group of variables on the final prediction, and is presented as predicted fatalities on this view. And then last, not live yet, but it's coming soon, is a map view for historic conflict trends. This will show the recorded conflict history from the Uppsala Conflict Data Program, or well, a views adaptation thereof, because we always adapt it to the views levels of analysis and have to make some tweaks to the data to suit our model. But this will be able to, you will be able to access this from the dashboard, both at the country level and at the grid level, so that you can go in and look not only at what informs the model, but also the data that we are evaluating our predictions against. So by going in and looking at, for example, the last conflict history recorded, and then looking at our predictions for the same month after we've retrieved the conflict history data for that month, you can get a basic evaluation, essentially, of our forecasts on a monthly basis. So we won't go in much more into the dashboard now, but wanted to give you a little bit of a peek into it. If all goes to plan, this dashboard will be live in about 1 to 2 weeks. So keep an eye out on our social media to see when it's released. And a huge thanks to Henrik, who has done all the amazing work behind this.
So I'll stop sharing and give it back to you, I guess.
Yes, thank you. And with that, I will hand over to my colleague, Sarah.
Yes, I will happily take over. Let's take a breather, everyone. We've been going for a good half hour now, so I'm sure there's a lot of information overload. I will quickly close this. So we have so far presented views, our early warning system, and some of our new features. And I'm here to basically show you how you can access our data and use it, because it is our hope that we have a lot of practitioners in the audience today who will want to use our data if they're not already using it. So as part of the proof of concept, we've also tried to improve a variety of data access methods that I'm going to go through today. So here you can see a screenshot of our website. I will, we've talked about the dashboard where you can kind of visualize the data, and I will show you 2 ways to download the data as CSV files. The first one is the download button, and the second one is the API. We also have on our website links to replication data, but these are mostly relevant for academic papers and less so for the early warning system. And you will find these under user guide and data access. So let's start the most simple use case if you're only interested in the most recent up-to-date data from our production models. There's a big fat download button under data, latest data. You can download both country month and PRIO-grid month data as a CSV file. And there is a corresponding codebook that explains all of the variables and what they mean. On our website live right now, we have the fatalities 002 model the run from December 2023. And this is a forecast for January 2024 until December 2026, based on input data up to December 2023. So that's as simple as it gets, really. If you're only interested in using it right now, this is where you would go for. However, we do realize that there are use cases where you would maybe be interested in comparing predictions that were done in different months, and this is when you would be using the API. So we have developed the API also as part of the proof of concept grant in our collaboration with UNESCO, which I'll talk about later. But you can use our API to query, access, and download all of the data sets that are in production. We have a Views API GitHub repository that I've linked in the chat before, which includes all of the source code and helper tools. And I will now take you through the 3 steps to access the data on the API. The first step is to identify your dataset and variable or model of interest. Then you make the API call either manually in the browser or in Python, and you download the data as a CSV. So let's go through the available datasets, which is quite a lot because, as I've said before, these are all of our monthly runs, right? Because we run our early warning system every month, and we have new data that's available every month. So we see here, for example, the top one in the screenshot is fatalities 002 2023-08. So this was our monthly run in August. The data sets contain dichotomous predictions, so conflict, no conflict, and continuous predictions, so the number of fatalities. They also contain the surrogate model results, which is the interpretation tool that we talked about before, and some historic conflict data. Although you'd be best off going to the UCDP API directly if you're really interested in having the most up-to-date data there. But this list of datasets is in the Views API GitHub wiki, for which there is the link here. So for us, the most recent dataset is 2023-12 T01. I think the main variables or models that you would be interested in accessing through the API is main mean, which is the predicted number of fatalities, main dichotomous, so the predicted probability of dichotomous conflict. And if you're interested, for example, seeing the isolated contribution from conflict history, you would be looking at the model called surrogate mean CH meaning conflict history. Then to make your API call, you've identified your data set of interest, which in this case is the most recent one from December 2023. You've identified your level of analysis, which could be country month, which we abbreviate as CM. It could also be PRIO-grid month, which we abbreviate as PGM. You've identified your type of violence, which for now is state-based, but it is going to be expanded to one-sided and non-state. If you're interested in the number of fatalities, you would be using the main mean model, and you would, if you're interested in a CVS, which I guess you would be, then yes, CSV. And it really is quite simple as copy pasting this API call into your browser if you want to do this manually, and adjusting the URL. A word of caution there, if you do download it and you open it in your spreadsheet Excel and it's exactly 10,000 rows long, that means that you have to run it again with page equals 2. If you don't want to do this manually, there's also a way to do it with Python, with it looping over the pages. And for that, we've also created a Jupyter notebook in Views Outreach / data exploration. You can run this on your own Jupyter notebook, or you can import it to Google Colab even. And yeah, that was it for the data access. I hope this was clear. There's plenty of documentation, and we're also happy to answer questions anytime. Now that you know, hopefully, how to access our data, we want to talk you through some use cases of the ways that you can use our data and ways that they've actually been used by practitioners that we've worked with. And this was also a big part of the proof of concept grant. So if you want to read more on this, you would have to go on our website, early warning system, user guide, and use cases. So some theoretical use cases, right? Most frequently, our data is being used to complement existing qualitative and programmatic assessments, right? Then this is really relevant for actors in the triple nexus, for example, in the humanitarian sphere, for kind of deploying resources for anticipatory action. And we've seen a lot of our collaborators integrate our forecasts into their own internal data dashboards. One other use case that I'm not aware of it being used, but I think it's definitely worth pointing out is for kind of agenda setting, funding, and advocacy levels, right? Because small local level NGOs or country offices can use our forecasts to compare the risk assessment of our forecasts with policy agendas, and even advocate for these forgotten crises that might be outside of the media cycle. Yeah, our data is being used by a bunch of international organizations and national ministries, for example, ESQA, the UK Ministry for Foreign Commonwealth Office, and the UNHCR. I'm going to talk you through 2 use cases and now that we have developed as part of the grant. The first one was a collaboration with the Peace and Development Unit at the UN Kenya Country Office, where our predictions were used to predict conflict in Kenya and for strategic planning and deployment of resources. So as part of this collaboration, the country office aggregated our pre-grid predictions to admin 1 levels because that just made much more sense for them. And this is definitely possible. Then the data was post-processed into a custom conflict risk index, which you can see in the screenshot on the right. So they actually turned the number of fatalities into a relative risk index, ranging from very low to very high, and visualizing this in admin 1. And then they visualize this in their crisis risk dashboard that they have with the UNDP. So we think this was a super interesting and fruitful collaboration. If you go on our website, there are also graphs on evaluating the resources, the predictions, and some more maps. Another use case is a custom bespoke model that we developed in 2021 for UN ESQA for their in-house data dashboard. That they use to quantify the risk of violence in the Arab region. And as we mentioned before, actually, this collaboration was one of the reasons that we extended our geographic reach to Africa, Middle East. So this was a commissioned research on the climate conflict linkage in the MENA region and the drivers of armed conflict. We developed a new bespoke forecasting models, as well as the API for the ESQA team to access the predictions firsthand. And as you can see on the screenshot on the left, this is their own risk dashboard for which they use our predictions. And yeah, having said that, I will hand over to Simon, who will talk a little bit more about future developments and what's in the pipeline.
Nice, thank you, Sarah. Obviously, we have a lot of things in our pipeline, and we could kind of differentiate between things that we are actively working on, things that are almost ready, and things we really want to be working on but need to push a bit ahead of us. But so these are the things that are most far along in our pipeline right now. So we are working on an easier integration with the views data into the dashboard. As was mentioned, the dashboard will be live. We are working on simplifying and making the API a bit more effective. We are also expanding and improving on our data sources. We want to go more granular for some hotspots. We are working a lot with new ways of imputing missing data and of aggregating or quantifying the uncertainty around this missing data. And also really quantifying the uncertainty around the data that we do have, but that we know is perhaps less certain than the data looks when you first look at it. We also want to expand the scope of our warning system. We want to have an actor level of analysis. So right now, as we talked about, we have country, we have pre-grid. We would like to have an actor level layer, so to say, where we can see or where we forecast the expected fatality incurred or produced, so to say, by specific actors. As mentioned, we want to incorporate the two other types of violence that are present in the UCDP data. And one of our major efforts right now is that we want to predict impact of armed violence. So this could be predicting food insecurities, they could be predicting migration patterns, they could be predicting gender security issue or changes in gender security situations. This is also to some extent connected to the interpretability challenges. We think that if you want to know how something is going to develop, we should predict that directly, and we should not leave it to our users to try to extrapolate from the surrogate models, because that might be that can be imprudent. As Angelica mentioned, these models quickly become quite complex. So more targets to forecast. We are working extensively on more quality assurance. So we are right now creating more live monitoring on our whole prediction pipeline. We are working on evaluating all deployed models and late-stage development models every month in a consistent manner. In the beginning of this will mostly be for internal use, but we are definitely having, talks back and forth between the deployment team and the outreach team in regards to what should go directly to users. So you can also pass the kind of the continuous performance of all our models. We also want to have easier time deploying new and diverse models. We have a number of very interesting models in our pipeline right now, but they are getting more specialized. They start to use new and different kind of data that we haven't used before, but we want to get them quickly into production. And then we also want to be able to retire outdated models quicker. We don't have, so all the models that we currently have are performing fine, but as we start to putting in new models, better models, it will become important that we can quickly take out models that for some reason or another failed. We are also working hard on predicting uncertainty around our estimates. So we don't just want to give you a fatality number, we want to give you a probability distribution around that number. So when we tell you that 1,000 people are estimated to succumb to conflict, we want to also tell you it's 1,000, but what is the probability that it is 2,000? What is the probability that it is 3,000? So we are moving hard on that. So the conclusion, can the prediction system be leveraged for conflict mitigation, peace building, and preventive efforts? We definitely see a grand potential right here, right? This was a number of these points were just mentioned by Sarah, but we do think that the products we have created can be very helpful to systemically identify areas of risk, and not least blind spot. I had a conversation with a colleague who told me that her and people from her team who were country expert would probably be able to beat our model at any one point. And I tend to agree with her, but like Google Maps, you could argue that a taxi driver already knows a city better than Google Maps would ever do, but we cannot all ask taxi drivers all the time, and all the taxi drivers cannot spend all their time looking for every road and for every museum in any city. Google Maps is super helpful for looking up where stuff are quickly and be sure that you can pass a whole city. In the same way, we are not saying that we can necessarily predict any specific development of a conflict better than a country level expert, but we can make sure that we survey large areas consistently and timely, and constantly. So that is a huge advantage of a live system like ours. We see by evaluating our models that we are pretty good at estimating the intensity of future conflict, especially for ongoing conflicts, how they are going to develop. We see that our estimates can be used to inform decision making in complex settings, and derive from that facilitate anticipatory action such as allocation of scarce resources, timely financing, or the identification and deployment of relevant personnel. Yeah, but naturally, it's not like we have solved conflict by now. There's a lot of limitations, and we are still facing a lot of challenges. A model right now, any machine learning model, no matter how complex, is only as good as the data informing it. So we are working hard to identify not just which features in our current kind of roster of features are useful, but also which kind of data sources we need to be better at incorporating going forward. This goes for unstructured data such as text and images, potentially audio and video further out into the future. The only one of these efforts that are currently far ahead in the pipeline is text, and then at very early stages, experimentation with images. We also need to be careful in figuring out which data sources we can expect are maintained frequently. Having data sources that are maintained once every 5 years when we try to create monthly predictions is not helpful. So we are looking hard into data sources that are continuously updated and well maintained. And then, of course, right, our predictions, no matter if you go for the probabilities of any conflict or the fatalities, these are best estimates of what our model thinks will happen in the future, giving the input data. It is not guaranteed. These are probabilistic statements, right? And they should be understood as such, right? And of course, as with the whole taxi driver Google Maps example, our models are probably used best in combination with area and conflict experts, especially if you have kind of the resources or the network to go over our predictions with such scholars. Yeah, and probably it's a good idea to go to our user guide if some of these things seems to need a bit more explanation. We do have a lot of documentation. Most of it is collected in central places, easy to find. Other information we can guide you to if you mail us. We have a lot of different documentation on GitHub, which is, at least to a non-technical audience, perhaps a bit harder to find, but probably also most relevant for a more technical user. So that's all I had.
Thank you so much, Simon. So we still have a few minutes to go. So if there are any further questions, I see the chat has been very active. I'm very happy to see that. But if there are any further questions, the floor is open. So please feel free to just turn on your camera or unmute yourself and ask, but you can also keep using the chat if you prefer doing that. All right. If there are no more questions, I think it's okay for us to round off here. But if there are any more questions further down the line, please don't hesitate to reach out to us. We're always happy to reach out to answer any questions you may have and help you make the most use of our data. While the proof of concept project is now rounding off, we are still always happy to collaborate.
I can quickly, so I can see that Andy Wheatley had a question that I can respond to verbally. I was writing a reply right now. You say just very quickly that as a non-IT expert, you have no idea what a CSV or Python file is, and you are not sure how accessible it is. So the dashboard will be non-technical use. If you can use any other dashboard that you can find on the internet showing whatever, click and point, you will be able to use the dashboard. If you press the big download button to get a CSV file, you will get what you have probably seen before in Excel or anything. A CSV file is a very kind of normal data frame file which is one of the most standard files used when you open any spreadsheet editor. So that is at least if you go as far as I've worked with any spreadsheet editor, a CSV file can be passed by that just as a data frame. A Python file is a small programming file. If you don't write Python, this is something that you shouldn't worry too much about. It is just when you want to interact more kind of in a more custom way with our data. Small scripts can be written by even kind of entry-level use of Python, and that might be helpful for people that need more custom outputs. But conversely, we cannot anticipate every kind of custom output people would want. So it would be, it would be beyond the scope for us to try to anticipate every kind of outcome. So this is just an opportunity for technical people that have very specific requirements.
All right, it looks like that was the last question. So thank you so much, everyone, for joining us. We're very happy to see such a large crowd. And again, please feel free to reach out if you have any further questions. And thank you again. Have a nice evening, everyone.